So this is some QC stats from the juicer pipeline. All of them are easy to understand. I guess you all know them. But I mean, they revolve around the same thing that we just heard. But there are some easy identifiable ones that you could pay attention to. And if you look at them, what kind of statistics that kind of pops out? This is a hint, for instance. And this is a hint. PCR duplicates and HiC complex. So this is the first batch of prepping, and this is the second batch. Same sample.
How many more reads now? Oh, yes. The number of PCR duplicates being dropped.
Yeah. So the first one was, well, all batches are done with nuclei isolation. The first one we suspected to work very well. But for some reason, we have low complexity and a high duplication. This is a 30 gigabyte genome. Yeah. And you see we have sequenced 500 million, and the library complexity estimate is roughly the same. So we have kind of out-sequenced this library, you could say. We have sequenced basically the same. That number 5, we have had little library there, so no reason to. So that's different. But the library complexity increases to over 2 million, right, and more. So here, from these libraries, we can actually sequence more without reaching saturation, basically. The difference between the two is that we started all over again with the nuclei, because how can you actually work with those library if there are so low complexity? At least you have to sequence several libraries. Since this was a large genome and costly, we thought it was best to start all over again. So we extracted the nuclei. It's actually 8 libraries we made on that batch. 4 of them are made with old-fashioned ARIMA prep with for plants, where you cross-link in those tea bags type of thing. It's a messy protocol. And then after isolating nuclei and then cross-linking. So kind of, but the results are basically the same. There are no difference there. So at least we know that you can just isolate nuclei and do the cross-linking on the nuclei and then freeze them and store them. So what went wrong on the first attempt? We don't know. We did the same. Or did we? I don't remember. But it just shows that sometimes things happen. Could it be the formalin, or is it some other issue going on?
Did you guys look at the integrity of the nuclei visually?
Well, I did that initially when I started with this nuclei thing, but you know, with a old microscope and you know, dirty lenses and super old oil and yeah, so it was more plant debris in that field of view. But I mean, the nuclear pellet seems decent actually, so and pretty clean. So yeah, high yield on the nuclear. Yeah.